Hello everyone, welcome to Rasayan Academy guys, and this is our second video in the series of Isolobal analogy, and I basically gave you some practice questions, and today we are going to look at the solutions of all of these 6 practice questions we had. All of these are from recent CSIR NET papers. They are all the PYQs that we are going to solve today. Okay, so the first one is the very simple one. We are going to start from a very simple question, that is asked in June 2017. Right, so I hope that all of you have already visited the previous video and you have already seen that what is isolable analogy. We have discussed it in a very nice method. If you haven't, I'll just put the link in the description, right? Okay, so let's move onwards. First of all, an organometallic fragment that is isolable to CH3 positive. Now this is CH3 positive which we want a organometallic fragment to be isolable with. Now the thing is, first of all, we calculate the number of electrons and the number of vacancies of electron, that is the number of holes. We have seen that already. So a carbon has 4 electrons plus 3 electrons from the hydrogen. Because there is a positive charge, -1, so this gives you 4 plus 3 is 7 minus 1, 6 electrons, and you know that the main group elements, they follow the octet rule. Okay, so they must have a total of 8 electron. So how much electron vacancy is there? So hole, which we call the electron vacancy, is 8 minus 6, 2. So we are having 2 holes. Now we are going to simply find out first of all from the hole analogy. So for option number 1, we have iron. Iron has 8 valence electron, that is the 3d6 4s2. Alright, so total 8 valence electrons we are going to take. Then carbonyl, it has 2, it donates 2 electron to the complex. So there are 5 carbonyl ligands. We are going to take 5 into 2, 10. So the first fragment is actually having 18 electron. So it is completely fulfilled. It will have 0 holes. The number of holes is going to be 0 because the organometallic fragments, follows the 18 electron rule. Right, so it has 0 holes. What about option number 2? Manganese has 3d5 4s2 electronic configuration, so 7 electrons, 7 plus again 5 carbonyl, so 7 plus 10, 17 electrons. But if it is 17 electrons, whole number matlab ki deficiency, that is equals to 1. Now for third option, chromium, it is 3d5 4s1, or you can totally take 6 electrons and again 10 electrons from the cobalt, from the carbonyl, so this is 16 electron. Now looks like this is going to be isolable because the number of holes is 18 minus 16, 18 because it follows the 18 electron rule. Total electron must be 18, that is why the same analogy, number of holes is equals to 2 right over here, and the number of holes is also 2 for the CH3 positive fragment. Okay, now option number 4, that is nickel. It is tricarbonyl and it has a positive charge. So nickel is 3d8 4s2. So it is going to be giving 10 electrons total plus 3 into 2 because every carbonyl donates 2 electron. So this is 6, right? And minus 1 because there is a positive charge. It would be 16, but minus 1 becomes 15 electrons, and the number of holes now is equals to 3 because 18 minus 15 is 3, right? So we can very clearly see that third complex, chromium complex, and the fragment CH3 positive, they are going to be the isolable to each other. Now this was based on the whole analogy. Let me quickly tell you one thing. I got a lot of responses and also one question regarding this, ki how are we able to know ki what is the frontier molecular orbital which the complex or the organometallic fragment is going to bring forward. So see guys, it is a fragment of an octahedral system, isn't it? If it is still having electron deficiency, it is going to fulfill it by bringing forth one more orbital and making the total coordination number 6. Coordination number 6 means that it is going to form an octahedral complex, right? So for now it does not have the possibility of octahedral complex, which means there is only one orbital which is remaining. Yes, now in a lot of examples, if let's say for the same complex I am having 17 number of electron, for example this manganese one, right? I am drawing the manganese one, I am having 17 number of electrons. Then for the same structure, it is also going to bring one frontier orbital, but that one frontier orbital is going to have one electron like this. Okay, and when there are 16 electrons, for example in the chromium complex, the orbital is going to be vacant. Okay, so this is how we define that CH3 positive. Once again, CH3 positive, you know, it is tetrahedral like this, and it is going to bring forth one frontier orbital that is vacant. Vacancy of 2 electrons but only one orbital, right? So these two are isolable to each other with respect to the whole analogy, or with respect to the frontier orbital. Now what about this 2? Yes, ये आपने देख ही लिया है. So let me also tell you that who is going to be isolable to this? CH3 with one orbital but with one odd electron. So basically the 7 electron system CH3 radical, this is going to be isolable to the second one. Okay, so I hope that now you understand what is the difference between finding the frontier molecular orbital. Okay, so yes, our answer for this question is option number 3. Let's move onward to the next one. Yes, so it is asked in June 2016, CPM. Now CP is your cyclopentadienyl anion, and it is eta 5 CP. Eta 5 matlab that is the hapticity. We already know what is hapticity. Matlab it is bonded from all of the carbons to the metal, right? So CPM fragment is isolable with a BH fragment. Now there is a little bit difference between a BH fragment and a CH fragment. What is the difference? Let's discuss. So the question is asking you simply that you have to find the N, which is what metal it is basically, that is going to be isolable with the BH fragment. Now understand this guys, that CH4, when we are beginning with CH4, you know CH4 is going to have 8 electrons complete, so it is going to correspond, or it is going to be isolable to a species, a organometallic species that is having 18 electrons. Okay, then CH3 has 7 electron, isolable to species having 17 electron, and so on. You can just go on decreasing a number of electrons, 6 electrons with 16 electrons. Yes, because the number of holes are going to be same. CH is going to have 5 electrons, C is going to have 4 electron, and so on. Okay, so it is isolable with 15 electron, and this is isolable with 14 electron. But what you have to understand, it is not same in the case of BH3. When we are starting with a molecule, let's say if we are starting for BH3, we need to understand that it is still having a sextet of electrons. It is having only 6 electrons, so it is going to correspond to a species which is having 16 electron, not 18 electron. Okay, because itself it is electron deficient. If we are starting with a pH3, for example, now phosphorus has all 5 electrons, isn't it? And 3 electron from hydrogen, so 8 electron system. Now this is going to correspond to 18 electron species. Now this is what you have to understand. Counting the number of electrons is very important. So for a BH fragment, if we want to see, for a BH fragment, we have started with BH3 corresponding to 16 electron. BH2 is going to correspond to 5 electron, 1 electron short, corresponds to the 15 electron system, 3 holes. BH fragment has 4 electrons. Why is this so? Because you already know boron has 3 electron, 2s2 2p1, and 1 from the hydrogen, so BH is having 4 electron. It is going to correspond to a species which is having 14 electrons. So now we just have to find that out of all of the options. Okay, so these are your option number 1. Yes, let's now see all of the options. Okay, so it is option number 1, for example, Cp gives 5 electron. Germanium is in the same group as carbon, group 14, so it is going to give only 4 electrons as the valence electron. Ye ho gaya 9 electron, so definitely not isolable because we want 14 electrons. Or let's say we want 4 holes. Yes, we want 4 holes, right? Now again on the Cp ruthenium, basically here we have 5 and ruthenium is going to give you 8 electrons, right? So it is now 13 electron system, but it has now 5 holes. Again, not isolable. What about option number 2, CpMn? Alright, so I've already clouded it. Okay, so 5 plus manganese is going to have 7 electrons. Yes, how much is it? 5 plus 7, 12 electron, and it has 18 minus 12, 6 holes. Definitely it is not the answer. About fourth one, ये देखो, 5 plus 9 electrons from cobalt, that gives you 14 electrons. So this is exactly what we want. We want the 14 electron system, isn't it? So it is going to have 4 holes, and yes, it is isolable with the BH fragment. Okay, now yes, this was a very simple concept that we had. Okay, so just by looking at the whole analogy, we can say that 4 is going to be isolable with the BH fragment in this way. Alright, so now we are going to move onwards, and yes, let's do another question. Question number 3. Among the following species, isolable to CH2 are, now this is very important because we have a lot of options, and this is a 4-mark question basically. This question is of 4 marks, okay? Yes, so let's see everything one by one. If you want to do it by yourself, you can stop the video and then start it. Okay, so option number A, let's see. CP, matlab cyclopentadienyl, eta 5. Chromium has 6 electrons, okay? And then again carbonyl. So there are 2 carbonyl, 2 into 2, 4. It is going to be 15 electron system. Okay, if it is 15 electron system, it has 3 holes. About option number B, 5 plus copper has 11 electron, guys. Yes, copper electronic configuration is going to be 3d10 4s1. Okay, yes, remember that. 16 electrons, so holes is equals to 2. Now for option number C, nickel. Nickel has 10 electron, it is 3d8 4s2, right? Okay, so 10 electrons plus 4 from the carbonyl, 14 electrons and 4 holes. D has 6 plus, yes, 6 plus 4 into 2, 8 electron. So this is going to be once again 14 electron system. Alright, and yes, further you have 4 holes for this also. Okay, and then further lastly you have iron. So iron is having how many electrons? 8 electrons plus 8 from the carbonyl, so 16 electron total. There must be 2 holes. So we have found out 16 electron species. As I can see, it is option number B and option number E. So looks like third is going to be the option. Yes, let's check again for the nickel dicarbonyl like this. Okay, so nickel is 3d8 4s2, so that is going to give you 10 electrons basically. And if it is given that it is going to be carbonyl and only 2 carbonyls, it is only donating 4 electrons, so this is a 14 electron species only. Yes, I'll just check out this question once again, might have been some misprinting or something. But yes, if we are having for this question right now, we are having option number B and option number E. Okay, I'll just link give in the description what is this question. Okay, so the answer has to be third one only, B, C and E. Chalo, let's move onwards. Okay, so yes, we did not find out for the CH2. Yes, so 4 plus 2 is going to be 6 electrons, and yes, whole is equals to 8 minus 6 is equals to 2 whole. Okay, so all of these 16 electron species are also going to have 2 holes. Now this is what we have, B and E. Okay, we'll have to check for the C option first. Okay, chalo, we move onwards. Yes, another 4-mark question. According to isolable analogy, the right set of fragment that might replace cobalt in this complex. Okay, so cobalt tricarbonyl. If you realize, if you break it down, you see that repeating this whole fragment 4 times, that gives you this final complex, isn't it? Yes. So what we are just going to do, I have already taken this example in the previous video, if you remember. So we are just going to find the number of electrons, 9 from the cobalt plus 2 into 3, 6. So this is going to be 15 electron species, and the holes R is equals to 18 minus 15 is equals to 3. 3 holes. Now we are going to look for the combination from 1, 2, 3 and 4, which can provide us 3 holes. So I am directly going on to the correct answer, because I hope that by now you can check for all of these. So if I find out for a CH fragment, it has how many? 4 plus 1, 5 electrons, and since it follows octet rule, it is going to have 3 holes. 8 minus 5 is 3 holes. For a phosphorus, so guys, we started from pH5 or anything. Phosphorus has 5 electron, 5 valence electron. So the number of holes are once again 3. Okay, so yes, the last one is nickel complex. Nickel eta 5 Cp. So that is 10 plus 5, 15 electrons over here, right? So if it is having 15 electron, 18 minus 15 is again 3 holes, right? So this is our correct answer, option number 2. You can try and check out for all of the other ones, you will be able to find. And let me tell you, if you get confused for SiCH3, guys, ये देखो SiCH3 is basically nothing. It is just that we are counting for main silicon. Silicon is going to have 3 frontier orbitals, because you know it is tetrahedral, right? So silicon is having 4 electrons because it is in the same group as carbon, and this methyl group, it is just donating 1 electron. So this is again is equals to 5 electrons total. Alright, but the other ones are not corresponding to 5 electrons, or let's say 3 holes, and that is why option 3 is incorrect. Okay, so yes, you will be able to check out the other ones as well. For this question, answer is option number 2. And yes, what do I mean by isolable in this question? That is, if you have a complex like this, that is, you are having a tetrahedral complex in which we are having 3. Alright, I'm just roughly drawing a possible structure. Definitely when there is cobalt and carbonyl, since cobalt is a 3D metal, there are going to be bridging carbonyls. No doubt there are going to be bridging carbonyl, but I am just randomly drawing a possible structure. Okay, so in this structure, if you want to check, every cobalt atom is going to follow the 18 electron rule. So it is a correct structure, just that from the IR frequency value we have the carbonyl bridging. Okay, so yes, if this is a possible structure, then we can replace one of the fragments of CO, carbonyl whole thrice, with either a CH, or which means that I can replace, and I can write a structure like this. Let's say CH cobalt CO3, alright, cobalt CO whole thrice and cobalt CO whole thrice. I can write something like this. Yes, just replacing a CH. Similarly, I can replace a phosphorus, okay, because it is going to provide equal number of electrons. That is why we use the isolable analogy to understand the concept of bonding. See, if we don't know the isolable analogy, it would be very hard to predict that why is phosphorus over here, isn't it? Or why is the CH over here? Okay, and you can also replace it with another organometallic fragment, that is nickel eta 5 Cp. Okay, so hopefully this question becomes clear to you. Let's move onwards to a 4-mark question, but at that it is very simple. Among the following, the correct statement is, so December 2013, yes, that is why it is easy for 4 marks. Okay, so which of the following is a correct statement? Now, just now we have seen that CH is isolable to CO, carbonyl whole thrice. ये अभी पिछले question में किया, not going to do that again. So this is your correct answer. You can check out for all of the others as well. So yes, CH is isolable. Electronically we have seen, and once again cobalt is going to bring forward 3 frontier orbitals, in this manner because it can have coordination number 6 at the max, right? So this is your isolable to each other, CH2, and you can count for all of these guys, they are all wrong. Okay, moving onwards to our last and a very fine question. ये देखो, in the cluster which is given over here, obeying 18 electron rule, very well, it is obeying the 18 electron rule. The number of metal bonds, so you have to find the number of metal bonds, and the bridging ligand respectively are. So you are very expert at finding the metal bond. You already know that you have to find the total valence electron first of all, then whatever the total valence electrons are, you have to multiply 18 into n is the number of metal, minus the total valence electron, divide by 2, that gives you the metal bond. Alright, you are very expert in that, but there is a short trick for these kind of questions. If you see that there is CO3 and a CH group, CO whole 9. So what does it look like? Can you replace, because you now know that the CH fragment is isolable to CO3 whole thrice. You can do it by that and it is going to very nicely explain the structure. Otherwise, if you just need to calculate, you know that CH fragment is going to give you how many? 4 and 1 from this, so 5 electron it is going to give you. But if you want, you can check out from this formula also. Okay, so yes, let's see quickly that if we replace CH with this fragment, let's see what happens. You were already having CO3, CO9, it is going to be CO carbonyl whole thrice. Isn't it the same thing that we have done? CO whole 4 and carbonyl whole 12. We have already seen the structure of this complex. It is going to have 6 metal bonds, isn't it? Chalo, let's anyways calculate. So the total valence electron now, it is equals to 9 into 4 plus carbonyl, right? So 2 into 12, that is equals to 36 plus 24, and that is equals to 60 electrons. So the metal bond we need to find up 18 into n. N is the number of metals. Here after replacing the isolable fragment we have 4 metals. So 18 into 4 is going to give you something like this, 72 minus 60 divide by 2, that gives you 6 metal bonds. But you don't have 6 in the option. Yes, you do have 6, but does not look correct. Why? Because in the question you don't have this fragment. Chalo, let's take it one by one. So ultimately for this complex, you know you are having 6 metal bonds. What does that give you? That gives you that 6 metal bonds are only possible in a tetrahedral geometry, because in a octahedral geometry, what do you have, guys? You have 1, 2, 3, 4, 5 and 6. Alright, and it is going to also have, let's say if the metals are placed like this. Okay, first of all you don't have 4 metals, yeah, the 4 ही है, so octahedral is not going to be applied in the coordination number 4. You can either apply tetrahedral or you can apply the square planar. So in the square planar you have only 4 bonds, 1, 2, 3 and 4. If it is 4 bonds, तो ये possible नहीं है. So definitely it is only going to be tetrahedral structure. Alright, now if we have the tetrahedral structure, there are 6 metal bonds, and now what you want to do is, since you already know the complex, you are just going to do a very little thing. You are just going to replace this carbonyl, or let's say this cobalt, just going to replace this cobalt and put a CH over there, because you have done so many examples till now. Just put a CH over there, right? So you have one bridging ligand, that is CH. Okay, and other than that you have how many metal bonds right now? 1, 2 and 3. Okay, so the 3 bonds are now CH bonds, okay, and the 3 metal bonds are remaining. So your correct answer is option number 1. Okay, 3 metal bonds and 1 bridging CH. Now we did this in a method using the isolable analogy concept for example, you don't use the isolable analogy concept. Let me erase everything. For example, you don't want to use that concept. How are you going to find the number of electrons? So let's do it once again. So see, there is something so important. You know that you have this ligand CH. Where is this coming from? It is coming from methane. So methane must have, or it is basically not able to donate anything. Why? Because it is not acting as a ligand. So if I am removing one proton, it is becoming CH3 minus. Now it can donate one electron. In the neutral method of calculating electrons, the anionic ligands correspond to one electron. Similarly, removing one more hydrogen, CH2, 2 minus is going to give only 2 electron, and CH3 minus gives 3 electron. This is how you are able to correspondingly understand. Now, if it is donate 3 electron, then what do you have? Cobalt has 9 electrons, so 9 into 3 plus 3 electron from here plus 9 into 2 is 18 electrons. So how much is it going to be? 27 sorry 27 plus 3 plus 18, so it is going to be 30 plus 18, that becomes our 48. Okay, so now you find the metal bond like this, because now 18 into 3 will happen, right? Because we are having only 3 metal. So 18 into 3 minus 48 divide by 2, right? So 18 into 3 we have 54 minus 48 divide by 2. Okay, 54 minus 48 is equals to 6 divided by 2, that gives you 3 metal bonds. So you can directly solve it even without you knowing the isolable analogy, and you know that there are going to be 3 metal bonds. Okay, you are having 3 metal bonds. Okay, so both of these options are wrong. ये दोनों हो सकते हैं, A and C. But you are so obviously you know that so obvious that when we are having a CH3 minus anion, basically this kind of a donor, it is definitely going to donate to 3 metals. That is why it is CH having 3 negative charge, isn't it? So the bridging ligand has to be one CH only. Alright, so these are two methods by which you can solve this question. It is a very nice question. All of the questions are nice. And yes guys, I will be uploading more videos in the inorganic section, so hope that you are studying from these videos. You definitely must, and you must also share these, guys. Okay, so yes, if you like this video, do give a big thumbs up and also share it please, because I am working very hard, and I hope that you will also share it with your friends so that they are able to learn from some free stuff. Okay, and also subscribe to the channel if you already haven't. And if you are wondering that how are you going to prepare for CSIR NET, then you can join Unacademy Plus. If you are liking my content, you can use the code Jagriti S. Now this code is for Unacademy Plus because you have to buy subscriptions. Okay, subscription which are time based, 1 month, 2 month, 3, 4, 3 and 6 and 24 months, like that. Okay, so yes, for more information you can join me on Telegram group, that is CSIR NET 2020. You will also find the link in the description box. Alright, so yes, I will see you very soon, and I hope to see you on Unacademy as well. A lot of free classes are also being conducted. Okay, so definitely join up, and bye everyone. We'll see you very soon.